So today I'm going to talk a little bit about finger photoplethysmography and a phonometer machine, which we use in the Human Vascular Control Lab as one of these ways to assess cardiac output. So start by turning the machine on. So once the phonometer machine is turned on, and we have a BeatScope program up on the computer which is connected to the phonometer machine, we choose the phonometer clinique setting. At this point, we are able to enter in the gender, age, weight of participants in kilograms, and their height in centimeters. Once it's all set up with the proper measurements for the participant, then it's time to hook it up to their finger. Once you have all of the information inputted, you're going to measure the size of the participant's middle finger around their middle phalange. So then you secure the phonometer front end unit onto the wrist of the participant, wrapping it around, make sure it's nice and snug, doesn't have to be too tight. Then you take the phonometer cuff that matches the size of the finger that you measured. So Katie was a medium, so I'm going to grab my medium phonometer cuff. You wrap it around the same finger that you measured, so the middle finger, around the fatty part around the middle phalange. So you want to wrap it pretty tightly, but you don't want to be cutting off circulation. If you give it a tug, you want to make sure that it's not budging and that the cords are coming out along the palm side of the hand. You can then bring the cord through the fingers and attach it to the phonometer front end box. At this time, it's important to consider the positioning of the hand that has the phonometer cuff on it. It should be in a relatively relaxed position. That's why we have this board for the participant to lean on so that they're not holding on to anything. Something to note is that Katie's hand is at approximately heart level. This is to ensure that blood pressure isn't increased to the finger if her hands were lowered or decreased to her fingers if they were raised above. We want to make sure that blood flow is as regular as possible. That's why we don't want to make sure that the cuff is too tight and that we regulate everything to be as normal as possible. Something else that could influence blood flow is the temperature of the participant's finger. If it's too cold, the phonometer might not pick up an accurate signal. If this happens, we can use a hot pack or a hot part of the body to warm up the finger or run their finger under hot water until it's warm. When the participant is biking, you want to ensure that any strength that they're using from their upper body is coming from their elbows. That's why we have this piece of wood here, allowing them to push through their elbows. Once the participant is all set up with their front end unit and the cuff attached to their hand and finger, you can press start on the computer. It will prompt you to press start on the phonometer. This is a good time to warn the participant that they will feel pressure in their hand. It's important to allow the machine approximately 5 minutes of data collection before you start your real data collection in order to assess that the values are an appropriate level and that the machine is working properly. As the machine is working, it recalibrates approximately every 70 heartbeats to ensure that it's keeping up with the information that it's getting. A way to know that the machine is not working properly is if it's recalibrating more than that. So every 10 beats, for example. In the research that I helped with, we were looking at a Wingate test, which is a 30-second maximal output test on a bike. We found that the phonometer was recalibrating too many times in that 30-second span to get appropriate data for analysis. Some ways in which you can avoid this is ensuring that the hand is as limp as possible. This is difficult in a situation in which someone is trying to put forth their maximal physical effort.
This is an example of a bad signal, which could have resulted from moving the hand too much or not keeping the hand limp. After the participant is all set up and the machine has been running for some time to ensure fewer recalibrations and a stronger signal, you may begin data collection. Finger photoplethysmography measures the arterial blood pressure by matching the pressure in the finger with an inflating air sac. From the blood pressure and heart rate measured at the finger, the BeatScope program on the computer can estimate the individual's stroke volume, cardiac output, and total peripheral resistance using the model flow method. If you follow this protocol, you should be able to get a good signal like this one. When you have finished data collection, be sure to turn off the program on the computer first and then the Finometer machine before removing the finger cuff.